Students, very welcome to this process of selection of the students for the GAABESU Research Fellowship or Research Scholarship support. Our objective to all of you is to encourage you for a good career, specifically in the research career in future. So you are very much welcome to make your presentation here, having some discussions with us. There are the people who are all our alumni of our institution, and we will try to give you some suggestions, discussions, etc. after your presentation. And in this process, feel comfortable. Never think that you are being evaluated. You are having a session of chatting with your seniors, and that will give you the maximum possible expressions as you can have with your seniors. So with this brief introduction, I just tell you the process, what you will do. Whenever somebody will present it, try to make it maximum 10 minutes. It can be even less than that. So consuming more time will go against your, presentation quality. So try to present maximum 10 minutes, or rather preferred if you can finish up in 8 minutes. Then we can have certain questions, discussions sort of questions. Not it is that what you don't, not to know what you don't know. We want to know, how you just interact with us. That's most important. So with this brief introductions, I think the first candidate, I guess Shubham is the first candidate, isn't it? So you are already visible. So if anyone else of the board has something to say, otherwise Shubham can start. Anyone has anything else to say? No. Okay. So Shubham, you can go for the presentation then.
Okay, sir, I'm starting. So now it is clearly visible.
It is coming. It is not yet come. Yeah, now it has come. So you can proceed. Your time starts now.
Thank you, everyone. Good evening, everyone. Please accept my humble obeisances. Here I am starting my research internship. I have done my research internship on dynamic wind effect of steel slipform structure, and under the mentorship of Soumyadeep Bhattacharyya sir and Swapnil Basu Bhaiya. So these are the content which I am going to describe in the my PPT, my presentation. First, the introduction of my research work, then the objective and scope and objective, literature review which I have gone through, the methodology which I have gone, and the result and discussion which I have finally got after the putting all the methodology. And at last, I have done about the conclusion of the research work and the references which I have taken for my research work. So this is the tall, the introduction. I have doing my research work on the tall this reinforced concrete chimney. It is located, this chimney is located in Vadodara, Maharashtra. It is 275-meter long, height of the chimney is 275-meter. And it is made up of the reinforced and concrete. Both steel and concrete is used in this structure. Initially, the base of the chimney was 27-meter, but as the height increases, so it has it reduces the height to 17. The diameter of the chimney is 17-meter. So here the slipform structure. Slipform is used for the construction of the chimney. Slipform is a process by which we can construct the chimney, and as the construction of the chimney goes, it can go up, and means as the construction completed of the one phase, it can go to the higher phase. It can go by two process, either the pulley, by the rope process it can go up, or the manual handling it can go. An advantage of the slipform construction in the chimney is that by this we can increase the speed of our construction of the chimney, and also many different gradation of gradation of the structure can be constructed by slipform process. So here the why we are doing the research work. So here the vortex effect is very important. So I want to just can I take so here the what happened in a tall chimney, if we consider this is a chimney structure in the top of the, so here if this side the wind is coming in this direction, so what happened, when wind is coming, a low pressure is generated around the wind, around the chimney in both the direction, and due to this the chimney oscillate in the perpendicular direction to the wind direction. I mean, in this direction, chimneys start oscillating. And what happened when this when this velocity, I mean, this frequency matches with the frequency of the chimney, so this resonance happen. And when resonance happen, the chimney can fall down, means it can collapse after some time. So this is the main problem of the chimney structure. Means what is the effect when we consider the wind load, wind effect. So now the scope and objective of my project research work. So I am doing a research work on numerical analysis of slipform structure, considering many effects: the vortex setting effect, the interaction between slipform chimney, and means my contribution is the uncertainty in the stochastic load. What happened when we are using the IS model, IS code model, the Gaussian model, and also the stochastic model. What happened to the across wind? That direction, in this direction, in the across wind method. So this is the literature review which I have gone through. This is the first, the interaction between the slipform and the chimney, and that is the Fosay sir has given. So there I have learned many things, and then the literature survey on the chimney slipform interaction, and then vortex shading effect. What is in the tall chimney? What is the vortex shading effect? And also the main is the literature review on the stochastic approach. So what is that which I am going to, which is my contribution. So the methodology which I have gone. So I have calculated the dead load, live load of the chimney and the slipform structure, the wind load along wind direction and the across wind direction. Across wind direction I have taken in three methods. First one is the IS code method, that is 4, 9, and 5, 2018 approach. And the second one is the Gaussian method. So this is a research work by a scientist. So from that, I have done the research. I have done the further research work on across wind method, and also the across wind to the stochastic model. So this is my contribution in this research work. So I have done the stochastic model of the across wind method, in which direction due to the vortex setting it can fail. So here, so this is a uncertainty method. Means here we can take a uncertainty factor. Also, this is a random factor we are using here. So this random factor can vary from 0 to 2 pi. So in due to this, what happened, because wind is a the dynamic force, it can have many higher velocity, also low velocity, and at high height it can have different velocity. So we are taking a random value. So depending on this, what is the happening on the slipform chimney structure. So after this model, putting this model, I have done my MATLAB calculation, and this is the graph I am getting in the force versus the time. What happened as the time increases? So what is the force acting on the slipform across a wind method? So after that, after my research work, so I have get into the result and result. So here, this is the three model I am taking across wind. First is the IS code method. So it is increasing linearly, and this one is the Gaussian method. So here, Gaussian method is IS method is taking us more closer to the original value. Means what happened to the chimney at the high edge. So it is taking more value. But when we take the stochastic model, so it is a large difference to the initial two. So this is the recent research work done by Datta in 2020. So here, due to this method, it has taking a high value. Nearly here, it is taking around 800 force. So this we are not considering initially. So this is the research work, and we find that due to this stochastic model, there is a large change in the wind load, which we are not considering in our while the construction of the chimney structure. And also when we have done the three approaches, the IS method, the Gaussian method, and the proposed stochastic method. So here the standalone modeling is the without chimney structure. If the chimney, without the slipform structure, if chimney is constructed and the slipform is not there in the top, means no more construction is going to happen. So what is the deflection? Maximum deflection. So here we see that the maximum deflection is in the stochastic model. And when we take the slipform also structure in the top of the chimney, so here we also see that the more deflection is in the stochastic model. So this is the conclusion I made from the research work, that we are taking the IS method and the Gaussian method initially. So, but this may not be the safe method. And also, what we are seeing that from the graph also, I have plot graph also, we are seeing that stochastic model is a highly means it is a very urgent need to implement this also in our construction of the slipform structure, which can help to last the slipform structure for a long for a chimney structure for a longer time. So this is the conclusion I am getting from the research work, my research work. And at last, I have taken few references which I am listing here. So these are the many references I have gone through. Means book also. And at last, thank you, sir.
Okay, Shubham, very nice presentation. I think you are very much enthusiastic, and the content also we have noted. Wish you all the best, but we will have certain discussions. I'm inviting the board members if they have any want to have some discussions with Shubham, please. So then let me start with maybe some other people will just join shortly. So the one of the issue is that you are telling that there will be a vibration out of that particular vortex shading, isn't it?
Sir, means
I
maximum
mean,
deflection. Yes,
yeah,
sir.
you are telling about that resonance and vibration sort of thing will happen, and all these are originating for the vortex shading, isn't it?
Vortex shading effect because of this.
Okay. Now,
Uh,
do you have any
it-
idea that how the frequency of that vortex shading and that's the main important problem, because if it becomes matching with the natural frequency of your chimney, then automatically there will be some resonance. Is it the issue?
Yes, sir. Yes, that is the only issue.
So,
This,
so can you just identify the frequency of vortex shading, because that becomes the most critical?
yes, sir. That we can means I don't have much idea. How can we can identify? It is means it is depending on the wind, how much the wind is in the environment, so that it can go up and also down. But we have to consider construct our chimney in such a way that at the worst construction also it can sustain. So the stochastic model give us so that the maximum value we can take, what is the current and at that location, what is the maximum it can go random value, and then from 0 to 2 pi we have taken random value, what is the maximum also possibility and what is the minimum, according to that we have constructed. So
Yeah. So actually, whenever you do some model means certain assumption based on that model is very important. You can
yes,
avoid certain large number of experiments by doing some modeling to get the initial idea. Then
yes, sir.
obviously you have to go for the experimentation before you go for your final decision. That's the standard practice in most of the cases. Okay.
Yes, sir.
So my question is, if you have any idea that which is the then, but we do the any modeling just with an objective for a real life solution, isn't it? Otherwise, the
Yes, sir.
modeling becomes meaningless. Now we are doing something with without any purpose. So
Yes,
from
sir.
that perspective, my question is very specific. Have you ever thought that which one is the most critical parameter for this particular work you have done? If the
Most I
wind
have
speed is high, so I'm giving you some hints. Wind speed is very high. Fine.
wind speed is high.
Wind angle may be a parameter.
uh,
Okay. So
and
there all
height
these
also, height
height
is
maybe
also
also the more
height.
the cantilever portions it's better. So any other
uh,
parameter which is most critical for this particular experiment? No.
Angle, as you mentioned, sir, angle of the that, and also the in which area it is located. If it
But
is,
but chimney is generally cylindrical. That means axisymmetric.
uh,
So what is your answer then?
I have not gone through that.
Okay, okay. Anybody else? Because Shubham has had some discussion.
am I audible? Myself,
Yeah,
Partha.
yeah.
Yeah. Shubham, what actually motivated you to consider the stochastic model over the physical models?
Yes, sir.
Why did you consider that we need to take up a stochastic model?
Sir, means initially when we take the IS code method, the 4995 model, 499 method, and when we go to the GSN method also, one scientist has means done that GSN method. So initially for the wind chimney structure, we consider only these two methods. for the across wind method. Along wind, we follow the IS code, but we don't consider the stochastic model. But that is a random, the random thing which can go up. So that I have taken.
What is the physical advantage of that? What additional physical feature can you include in this model over that of IS model?
So if we consider the stochastic model also, so the chimney can last for longer time because it is taking the maximum extent of what is going to happen when the vortex effect is high. So that the physically it can stay for longer time. That is the main purpose.
Okay. Thank you.
Hey, Sudipta, although I'm not a member of the board, this is Biman in 1981 Metallurgy. Shubham, just one quick question in line with what Professor Chatterjee just asked you.
Yes.
In terms of reducing uncertainty with respect to the stochastics approach, right?
Yes.
So I am really appreciating your work because you are looking at very recent works like 2020, etc. Is there any specific chimney that is constructed based on the stochastic model, or it is just a proposal that is going to consider all other stresses that might impact the life and the factor of safety of the design?
So this is a proposal which we are doing research work. This is not constructed yet.
Okay. Thank you. Great
Thank you,
job.
sir.
Sudipta, you are muted.
Anybody who has any other questions? Or from the alumni also, small questions can be. Otherwise, I think Shubham has spent us a nice time with us. You happy with us, Shubham?
Yes, sir. Happy.
Okay.
Thank you,
So
sir.
I think now we can go to your next friend. Thank you.
Thank you, sir.
Okay. Shabanda, so you have to rather rope in the next person, or whether Shubham will continue to stay, or you can decide. I can guide him accordingly. Shabanda?
No, you can invite the next candidate. Who is the list in the tool?
Tool has to tell it, no? So the next candidate in the list, I can
Maharnab
also.
Kundu.
Maharnab Kundu.
Oh, Maharnab
Yes,
Kundu.
good evening, sir.
Hmm.
So let me present my screen. Let me know if it's visible.
So as you have seen your earlier friend, I think you are comfortable with doing what we're expecting from you. Within 10 minutes, you try to finish up. It's lesser than 10 minutes, will be even more credit.
Okay, sir. Is my screen visible?
Yes, but you have to go for the full screen.
I think I'm having some problem. Let me share once, sir.
Is it most probably F5 or so? That can directly take it to full screen?
Let me try, sir.
Okay.
I am having some problems, sir. What to do for full screen,
No,
sir?
no,
Can
no,
you
no.
please guide me,
Your
sir?
presentation is visible, but not in the full screen mode. So what you can do, if it is not done, then you can start from here itself. No problem.
Okay, sir.
Little bit more clarity, but it's okay. Just go on presenting. Your time starts now. Okay. Yeah, that's absolutely nice. Now it's working. Okay, sure. Yeah,
Okay,
sorry, Maharnab, start.
So, yeah, so my work is on improved sustainability measurement procedure for concrete buildings. So I have also been guided by Professor Soumyadeep Bhattacharyya during my second year summer vacation to do this research project. So this project originally develops from a Spanish structural concrete code. So the motivation behind the project is that the environmental sustainability is a major concern for our recent construction industry and every industry. And construction industry is a major industry that contributes to a lot of pollution. So I will describe a mathematical model that we have developed from the previous studies, and we have improved the model to include the volumetric ratios of different material as used in construction. So here are some studies that I have reviewed to do this project. So the main paper was this first paper, the structural assessment of concrete structure within the Spanish structural concrete code. It is a ASC paper published in 2013, where they have discussed the index of contribution to environmental sustainability. That is the ICES model. And we have improved the ICES model to make it MICES, that is the modified ICES model. So also we have studied many more studies which have used similar mathematical models to describe certain different things like housing interior in Iran. In England, UK, they have used the mass weighing criteria for different building systems. And in Spain, they have also used this type of mathematical models to, to analyze their government projects like buildings, mass housings, and the other things. So here are some mathematical models that I have compared here. So this is the main mathematical formula. There is the ICES, that is A plus B. A and B are two different coefficients representing different contribution due to different economic and social and environmental sustainability. And here are some more mathematical models based on the same statistics. That is the MIVS. I will explain it later. So what we have taken that this volumetric weight decision criteria. So this is the Spanish structural concrete code, which if we translate in English, this turns upon the integrated value model for sustainability assessment. In their Spanish language, it is abbreviated as MIVS. So this is the index, that is the ISMA index, where it depends upon the four major factors: alpha, beta, gamma, and V. So there are 11 different criteria that should be considered. So these are the different criteria. As we can see, the characteristic of concrete subtier, characteristic of reinforcement subtier. So this is a tree type of model. That is, it depends upon the different environmental sustainability for different level of criteria. That is the criteria level, sub-requirement level, requirement level, and assessment level. So at criteria level, it is the basic level, most basic level. Characteristic of concrete supplier, characteristic of reinforcement supplier. If the reinforcement is environmentally sustainable, there is still characteristic. Reinforcement reduction criteria: is the design optimal to use less steel or less concrete, or is the steel recycled enough? That is the recycled steel that is more environmentally sustainable. So VI is the value factor determining each criteria according to the this expression. It is an exponential expression where KI, MI, NI, these are the different small factors that have been broken into different small parts as per the Spanish structural concrete code, that is the EAG 08. And like this, after that, we get the ISMA value from there, and we have to multiply A and B. A is the social contribution factor that is determined by the sum of different factors from this table 13.5 of the Spanish code. And there are 5 different criteria from the different models. And B is the working life. That is, if a structure's life is long, then it is more sustainable. We have to pay less. It is also economically sustainable. And from this model, we can get 5 different level of environmental sustainability from where A to E. A is the maximum end of the scale and E is the minimum end of the scale. So here we have considered the ISMA considers the environmental impact of the ingredients waste recycling, particularly the ferric waste and the decreased CO2 emission, steel production, level of execution control, and the different type of mixing of type of concrete. Like, sir, I would like to give an example that if concrete is mixed on site, there is more pollution. There is more dust pollution, air pollution, and different kind of things. Contractor may have to take different precaution to prevent those things, like spraying water or using some kind of barrier to prevent those things. Those are less environmentally sustainable. So what they have seen that the concrete that is pre-mixed from ready-mix concrete plant, that is more environmentally sustainable. And there is some kind of concrete that is the precast concrete beam, precast concrete column, that is more environmentally sustainable. It is coming precast from the factory, so we don't have to like make the concrete, make the design, everything. The engineers design them, it is mass produced in factory, so that is more environmental. Like that, the Spanish code gives them different values like 0.2, 0.3, and like this. So here we have taken the materials that we use in our day-to-day construction in our country, like in India. So we have like reinforced concrete construction, clay brick construction, autoclave variated AAC brick construction, fly ash brick construction. So from our literature review, what we have found that they have given some environmental sustainability index values to those each of the materials. So what we can infer from that, that autoclave aerated concrete may be 1.33 times more environmentally sustainable than reinforced concrete, because it is precast, it is coming from the factory, it is mass produced. So similarly, clay brick and the fly ash brick are more like 2.08 times and the 2.16 times more environmentally sustainable than reinforced concrete. So like this, we can compare different values and we can get this 1, 2.08, 2.16, 2.33 for different materials as compared to reinforced concrete. Then we have calculated the volumetric contribution for each material. Like we have concrete columns, concrete footings, but we might have clay brick walls or autoclave variated AAC brick, like we have the parapet walls or the non-load bearing walls. So there are different materials which have different volumetric contribution to the whole project. So this is the modified value where we have multiplied the different values, that is the summation of different values and the relative environmental sustainability assessment of their materials. And then we have proposed this MICS, that is the modified ICS model. So similarly, if we use like for 50% for RC construction and 50% is clay brick, as I have given that example, that concrete columns, concrete footing, and clay brick walls. So if there is 50% of material used, then it can also be used like this, like 1.54. So here we have also conducted a numerical study based on this drawing. So here column size is 250 cross 250, shaft thickness is 150 mm, and the grade of concrete M20 and steel is Fe500. So inner and outer clay brick structure, and it is 300 mm thick. So what we have found that the existing model gives 0.14 this value to every material, which is not correct. But our own model, that the modified ICS, MICS model, gives different value to different material. So we are getting an interesting result that we can compare different material for their different environmental sustainability. So we are getting that the load bearing clay brick has the highest MICS value, that is, and the autoclave variated concrete AAC brick is the lowest MICS value.
You need to wind up fast, huh?
Okay,
need to wind up fast.
Okay, sir. So what we have found that the RC system analyzes clay brick infill, enhances overall sustainability, and AAC system is lightweight and cost effective. And the new ES measurement is the construction project. A modified value of ICS is defined, which is taken into account for new environmental sustainability measures, and the effectiveness and the proposed of environmental sustainability approach is well established with the two-story building from our numerical study. So here it is our conclusion that the approach is developed is generic, but it can be applied for any kind of construction. But for the better understanding of our model, we need huge data, which is not so much possible to collect in our country, where the construction industry is not so much regulated. So here are a few references which we have used in our study. And thank you very much, sir.
Yeah, Arnab, it's a very nice presentation. I mean, before the others start discussing, I'm just going for a very fundamental rather query. Sustainable is in word available is a word available in dictionary. That's meaning is very clear. But is the sustainable has any relations with the United Nations? The term sustainable has any relations with United Nations? Do you know it?
Sir, sustainability came up like after like 1950, when we get to know that the global warming and the ozone hole destruction and all the other things, and when we get to the key cause of the all the effects, then we have found that the more carbon emission, more construction, more like construction is a huge part of our pollution thing. So
Yeah,
United Nations came up.
Carbon emission is related to climate change. But does the
Yes,
sustainable
sir.
development is the sustainable? You are aware of the term sustainable development? No.
Yes, sir.
I mean, does it have any relations with United Nations? Yes or no? No. Okay, fine. So I think the
I think no, sir. It's a global term.
Development goal.
Yeah, sustainable development goal. Parthoda is asking. Any idea?
Says sustainable. There are 8 criteria for sustainable development goal. I couldn't remember every term, like, but I know that there are 8 or
And the
10 different points that
also
they
is-
have pointed out.
Okay. The point is, whenever you are going for the
Goal 12
index,
is directly related to your work.
Yes, sir.
anybody else has any queries? Yeah. So my idea is finally in that case, Niyarda, are you going to ask something? No.
I just wanted to ask.
Yeah.
Sorry, Maharnab, that one of the slides at the very early, you talked about value factors. Do you remember?
Yes, sir.
Yeah. How and those value factors, how did you choose those numbers?
Sir, the numbers that we have used in our study that came from the Spanish Structural Concrete Code EH08 or from the established research that we have reviewed in our literature.
But how did you, like, you just took it the same numbers across for your study?
Yes, sir. Like the numbers which I have taken, I have excessively marked them that this is taken from this study. I have marked.
No,
that
I
study.
understand, but I'm just saying that we varied, say, for example, 0.17 to 1, right? Something
Yes,
like
sir.
that, right? There's a
Yes,
lot
sir.
of variation there. So you are using those numbers directly. Do you know whether this was feasible for your study? This is the right numbers. That's my question.
Yes, sir. Actually, this is a hypothetical mathematical model. So to establish the model, we might have to run the model through huge number of data. So this data is like should only be accessible from the construction industry, like who does the construction. That is our, and in our country, in India, the construction is highly unregulated, like highly decentralized, and the data is not easily acquirable. Like there are different regulations that you cannot accept this data, or you cannot use private data and all the other things. So there might be some irregularity in the model, but it is a highly generalized model, sir.
Yeah, thank you.
Parthoda has a query. He's raising his hand. Yeah, Parthoda.
Your work was focused on environmental sustainability. Now, from your mathematical model, what I could understand, mostly you have considered material aspect, but how you have considered environmental factors in your model? I mean, changes in environment, Because sustainability, we understand the ability to adapt or to absorb the changes, intrinsic and extrinsic. So how did you consider the changes in environment, or have you considered environmental parameters in your model?
Sir, environmental parameters like can you please clarify like what, sir?
Environmental parameters means for a particular construction, what is the climatic situation, what is the proneness to earthquake, whatever it is, or
Yes, sir. It is
susceptibility
that.
for any aggressive change,
Yes,
say
sir.
seashore environment.
Yes, sir. Yes, sir. There is different environmental value models. Like I have shown you the 11 different criteria, the tree model, and that is the highly generalized model, sir. If you go through the
I
original
understand, but
model
what are the
from the Spanish
specific
code,
environmental parameters?
yes, sir, there is specific environmental parameters embedded inside the tree model, sir. I cannot show you in the short presentation, but there is.
What are those parameters, and what kind of variation in those parameters have you considered?
Sir, if you allow me, I will love to show you the code. I have opened the code in my laptop.
I'm just asking that because you are developing a model, so a model cannot ignore the physical situation because it is a physical model. It is not a data-driven machine learning model. So
yes, sir.
If it is a physical model, you cannot ignore the physical situation or physical understanding.
Yes, sir. Like the humidity on all the other things.
Yeah,
exactly.
Yes. I mean,
humidity temperature on the yes, sir. Yes, sir. As I have told you, sir, it is a generalized model, sir. We haven't gone through like the data and all the other
Otherwise,
things.
it is a good effort. Thank you.
Yeah. I think we should encourage Maharnab for the better. You always, no research can end anytime. So you can go on doing those things later on, carry on according to the suggested by your our alumni, Professor Dr. Chattopadhyay. So nice presentation. So we can go to the next persons. I think all the board members are agreeing now. So we can go for the next presentation. Okay. So third one, Tultul.
Udayan Dash.
Yes, ma'am. Just one second. Let me share my screen.
Yeah. Unfortunately, my video is not working. Anyway, I'm here. No problem.
I think it's visible, right? The screen?
Not yet.
No.
Is it visible now? Is it visible
No.
now?
Now it's coming. Yeah.
It is visible.
Yeah, now it's visible.
Okay.
It's visible. Okay, so you go for the full screen if possible.
So it's visible, right? Yes, sir. It's visible. The full screen.
Yeah.
Yes.
Now it's good. Please carry on.
Okay. Good evening, everyone. My name is Udayan Dash.
There is an echo.
Respected delegates and yes, sir.
There is an echo. Maybe two devices you are using simultaneously, very close. That sometimes cause the echo. So just check whether you are in only one device or two devices.
Sir, is it okay now?
Anyway, you can carry on. You can carry on. Let's see what happens.
Sir, is it okay now? Sir, am I audible?
It is a little bit lesser sound, but we can no echo is there at least. Okay, carry on, please.
Okay, sir. Okay, sir. So the topic of my paper today is experimental and numerical study of drag due to flow past a 2D perforated cylinder. Now, this study was actually like after the end of my second year, I did an internship at CSIR-NL, Bangalore. So the internship was done under a guide, but it was purely experimental. So this is actually an extension of it. Now, here I've even included the numerical study, like in through ANSYS student, and then I verified the result, and this was done independently. So let's start. So the outline, so the basic outline of the paper, as we can see here, it is the primary objective is to investigate the drag coefficient. Now, when I see drag, we are investigating the drag coefficient here because that is a dimensionless value and that does not depend on the dimensions of the body that is being experimented on. So here we're going to investigate the drag coefficient of a 2D perforated circular cylinder, and we will verify the optimum value of the perforation size for minimum drag coefficient using CFD simulation and ANSYS student. Now here the perforation size actually like on the body of the circular cylinder during the experiments, we made a number of perforations in the stagnation region. One is the forward stagnation region and one is the rear stagnation region. Now, stagnation region for a body is basically it's a point or a line on the body where the absolute velocity, where the velocity of the flow of the fluid over the body is zero. So that is known as a stagnation point or a stagnation region. So the range of velocity used for the experimentation was 5 meter per second to 28 meter per second, with a step size of 5 meter per second for each value. And the corresponding Reynolds number range was around 13,000 to 68,000. It changed like 13,000 to 26,000 to 39,000, 52,000, and then finally 68,000. So, 1 second.
Move a little bit faster, otherwise you will not get enough time to conclude your results. No?
Actually, my screen is lagging, I think. Just 1 second. Sir, can I present after some time? I think there is some problem here. Can I present after a while? Until there's like someone else can present.
You can come out and then restart because you are already in the scene. So just try once, stop sharing, and then again enter. That can be one option. Yeah.
Yes, let me check. Yes, sir. Yes, sir. Now it's working. Okay, so here is the diagrams, the figure 1 and figure 2 that you can see. Now this the experimental study was done inside the wind tunnel of CSIR-NL. Now the figure 1 that you can see here, that is actually the inner part of the test section of the wind tunnel. And the figure 2, we can see how the model actually looked like. Now at the very base of the model, you can see that there is a 6-component load cell which was attached. So that actually measured the forces that was there. So that measured the forces like Fx, Fy, Fz, and a moment about the 3-axis. So that is like a 6 degree of freedom load cell. And the side view of the cylinder is shown here. This is the perforations, and if you look closely, the perforations are even visible on the body of the cylinder here. Now the baseline data. The baseline data was actually the cylinder without any perforations on it. That was the baseline data. Now the baseline data was actually verified with existing literature by Dr. Bierman. Now according to this, now figure 4 is the existing literature and figure 3 was a plot that I got. Now for Reynolds number of this range, that was from 13,000 to around 68,000. The value of the drag coefficient is coming close to 1.2, which is actually verified from the plot here. As you can see, the CD value here is also close to 1.2. So our experiment is on the correct track. Now after that, like after the experimentation, these results were obtained. Now in these results, how we made the perforations were actually like in one of the stagnation regions of the cylinder, the perforations were kept constant at around 1 mm. And after that, and for the other stagnation region, the diameter of the perforations, it was changed from 1 mm to 1.5 and to 2.5. With a step size of 0.5 mm, we were like continuously increasing the perforations. Now the left side graph that you can see, that is the baseline drag coefficient of the cylinder, like the trend of the baseline drag coefficient to the perforation size of 2 mm in the front stagnation region, perforation size of 1 mm and then 1.5. So we are getting the minimum drag coefficient for the perforation size of 1.5 for both the orientations of the cylinder. Now numerically, we are going to verify the exact same thing. Now here for the numerical simulation, this mesh was made. You can see this is the ambient flow field and the cylinder is somewhere in the center. And this is the magnified view of the mesh around the cylinder. Now, the thing is, now another thing to be noted here is that I did not mesh the wake of the cylinder. Like I did not refine the mesh at the wake of the cylinder because wake is not the like in this paper we are not studying the wake of the cylinder. Basically, we are studying the flow over the cylinder. So by making this mesh, I actually reduce the computational time and the computational power. So less computational time and power is required for this study. And apart from this, the operating condition for all the simulation got a pressure of 101.325 Pascal, or just the normal atmospheric pressure. And standard K-epsilon viscous model for use for the simulation with the higher Reynolds number, 52,000 and 65,000. Meanwhile, the viscous laminar model was used for the lower Reynolds number. Now these are the results that were obtained from the numerical simulation in ANSYS 12. Now this is the result for the baseline data, and we can see that just like the experimental data and just like the existing literature data, the drag coefficient past the cylinder should be close to around 1.2, and that is even visible here. It is close to 1.2. So the numerical simulation is going in the correct direction. Now the upcoming plots that you can see, those are for the other orientations of the cylinder, as you can see. So I will just go past all this and I will directly come to the final result here. Now the trends can be seen below. Here, these are the legends that are given. Now these points which are in black, those are for the baseline data, where the forward stagnation region, and the left plot that is for the forward stagnation region, perforations were of higher diameter, and the rear stagnation region perforations were kept constant at 1 mm diameter. And the plot on the right, that is for those orientations of the cylinder where the forward stagnation perforation was kept constant at 1 mm and the rear stagnation perforation were changed. Now here we can see that the baseline drag coefficient, sorry, and here one more thing that I want to add here is that the x-axis, it actually represents the Reynolds number. I forgot to label the axis. The x-axis corresponds to the Reynolds number, and the y-axis corresponds to the drag coefficient of the cylinder. Now, for the baseline data, we are getting the highest drag coefficient, which should be there according to the experimental data too. And for 1.5 mm perforations, we are getting the least. And this is actually verified. This numerical solution, this actually verifies the experimental data too. In the experiments also, we got the same result, which was for the perforations of the 1.5 mm, the drag coefficient was the lowest. Now, both of this phenomena, even for the perforation size, if it is higher in the forward stagnation region, we can explain it using the equation of continuity in fluid dynamics. Now according to the equation of continuity, what actually happens is, if the exit area is reduced, the flow velocity should increase. Like this is for incompressible subsonic flow. If the flow area is reduced, the velocity of the flow should increase, and that is exactly what's happening here, because as the perforation size is being increased, there is a thrust that is produced against the flow, and that is detected by the load cell, due to which the drag is lower, due to which the drag is reduced. But there is a certain trend reversal that we can observe here. That is, after 1.5, when we reach the stagnation, when we reach the perforation size of 2 mm, we are getting a trend reversal in the graph. Now this is because, ideally, what should happen is for 2 mm the drag coefficient should be minimum, but that is not the case here. That is because after a certain point, the obstruction of the flow is so high that even after the thrust is produced, it cannot dominate over the drag. So that is exactly what is happening here. The optimum size of the perforation for this cylinder is 1.5. For this cylinder, I'm saying because this cylinder was actually a hollow cylinder with a diameter of around 40 mm, and the thickness was very low.
Yes, please wind up. Your time is short. Yeah.
Yes, sir.
Levels crossed.
So finally, we are coming to the future scope. Okay, just 1 second. This graph I did not explain. Now for this graph, when the rear stagnation region perforation size is higher, that can be explained using the Bernoulli's equation actually. Now, for the Bernoulli's equation, when the velocity is lower, because in this case the velocity is lower at the rear end. Now, when the velocity is lower, the pressure is higher. Now, the pressure is higher, it pushes the cylinder against the flow, and again the drag is reduced. But at the same time, but similar to the first graph here in figure 27, we are getting a trend reversal here at 2 mm. So the optimum value is 1.5 for a cylinder of diameter 40 mm. Now, if the cylinder diameter is changing, we can use the ratio, that is 1.5 by 40, and we can find the new optimum value of the perforation size. Now, future scope and industry application for this study was actually a reduction of drag. Now, this study can be extended for airfoils and for practical aircrafts. Now, drag reduction, if the drag is being reduced, lower fuel is being consumed, and if lower fuel is being consumed, the carbon footprint is also getting lowered. So that is one industry application. Like this has not been used yet. First, you have to check it numerically for an aircraft, and then if the numerical solutions are promising, then we can use it for the experimental. Then we can use it for a practical aircraft too. So that was the end of my presentation. Thank you.
Done. It's a good presentation, but you have taken a little bit more time. Anyway, that's an enthusiastic presentation. So there was some technical problem also related to you. May not be fully you are responsible for that. Anyway, so my only one question is, you have mentioned about Bernoulli's equation, no?
Yes, sir. Yes.
So do you know any equation called Navier-Stokes equation?
Yes, sir. Yes, sir. I know the Navier-Stokes equation.
So what is the basic difference between these two? Any idea? Just fundamentally.
Sir, in the Navier-Stokes equation, actually the density term also comes. Now, density, like for a basic incompressible inviscid flow, we can use the Bernoulli's equation. Now, for a compressible, for a more complex flow, we can use the Navier-Stokes equation, which is like this can be explained using the Navier-Stokes equation too, but that would just complicate matters. So I haven't used it there. It was just a basic incompressible flow, so that's why Bernoulli's equation is enough for this.
Okay. So Navier-Stokes can be derived from Bernoulli's, or Bernoulli's equation can be derived from Navier-Stokes? Any idea? No.
Sir, I don't have the idea, but I can. Okay, but most probably, like the Bernoulli's equation can be derived from the Navier-Stokes.
Okay, thank you. So, any other members here? Parthoda, do you have something to ask? You have to unmute yourself at first. You have to unmute, Parthoda.
In your result, it's just a query. The variation between 1.5 millimeter and 2 millimeter, do you think it is physically significant, or it is kind of error limit some sort of? Because you are predicting a reversal between 2 to 1.5.
Yes.
So the variation there, apparently it is not physically significant in comparison to between 1 and 1.5. So is it a physically significant measurement, or it is an error?
Sir, actually here, like we have to see the ratio, like the diameter of the cylinder we have taken as 40 mm. Now, we can say that for 1.5 mm, like this is applicable for this type of cylinder. Like the optimum value, instead of optimum value, we can call it the optimum ratio of the perforation size is to the cylinder diameter. So instead of 1.5, we can say that the optimum ratio should be 1.5 to 40. Now, what actually happens is, like when we increase it, like from 1.5 to 2, like the thrust effect, like micro thrusts, like those are definitely present according to the equation of continuity. But the obstruction of the flow is also very high, that such that the thrust force actually cannot dominate over it. So that's why there is a trend reversal, and the drag coefficient finally increases. So that's what. At the end, I also said that for a cylinder diameter, for example, for 40 mm diameter, we are having the perforation size of 1.5. But if we increase the cylinder diameter to say 80 mm, now in that case, maybe it is close to 3 mm. The perforation size should be close to 3 mm. So that's the thing.
My point is different. My point is, when you are comparing 1.5 and 2 millimeter, you are proposing some phenomenological observation for the reversion, right?
Yes.
Now, such an observation should be consistent if your measurement is physically significant. But apparently, when we compared the variation between 1 millimeter to 1.5 millimeter and between 1.5 millimeter to 2 millimeter, it seems not very significant. That was my query. Yeah, okay, I got my answer.
Yeah, Niharta, do you have anything to ask, or any other board members?
Oh, I'm good. Thank you.
Okay. So I think if no one else has any queries, we must congratulate Udayan for a very good presentation. And we are appreciating your presentation, your research. So let's go to the next friend. Okay, thank you, Udayan.
Next
Thank you,
is
sir.
Arghya Pal.
Arghya Paul.
Yes, ma'am.
Please go for the presentation. Remember that you have to finish up before 10 minutes. That means 8 minutes is quite optimum. Don't exceed.
So, good evening, everyone. I am Arghya Paul from Department of Aerospace Engineering and Applied Mechanics. So, here I am presenting my project on experimental determination of heat of combustion values, viscosity, surface tension, and density for different jet fuel and propanol to blending. So, these are all the properties of a fuel which should be determined to judge the fuel is applicable for using in a commercial vehicle or not. So this is the outline for my presentation. So the the motivation behind this project was to consider the pollution coming from the airline industries. That is basically 2 to 3% of global carbon emission and less than 3% of global NOx emission, which is coming from the airline industry. So this is the primary motivation, and our objective is to find the accommodation of a new blending fuel in the industry. So that's why we are finding the fuel properties here. So this is the literature survey done by Christiana and his team. So they suggested that isopropanol, which is basically a propanol 2, that can be used to minimize NOx emission and obviously to minimize the carbon emission. Also, this has a potential to use as a fuel. And next, Karmakar and his team, they also conducted one experiment on butyrate and jet A1 fuel blending. So they showed that this kind of fuel can be used in commercial vehicle without changing the engine configuration, basically, which is a great advantage for our industry purposes. So this is total fuel composition which we have prepared. So there was pure jet fuel and also blended with isopropanol, ethanol, copper chromate, which is solid substance, ferric oxide, cupric oxide, and cobalt oxide. These are the oxide which have used to check whether the heat of combustion value is increasing or not, because this solid substance act as a catalyst. So that's why we use this. Our primary goal was to find the suitability for isopropanol, and ethanol we just did it for our reference purposes. So this is the experimental arrangement which we have, that is automatic bomb calorimeter and the microprocessor. And the heat of combustion values is calculated using Q equals to WT and minus T. This is the formula basically which we have calculated. And the process is like first we have took the one wire and then thread, then we separately measured the components and prepared the samples, and then we immerse the sample into the basically thread, and then we make the bomb apparatus. Then this is temperature probe which we have done, which we have imported in jacket, and also microprocessor that calculating the heat of combustion values basically. Now I'm showing for the determination for viscosity basically. So this is Anton per rotational viscometer which we have in our lab. So we prepared the sample, and just there was one cylinder which is attached here basically. So there we put the cylinder and it just gave us the values of viscosity. And now for surface tension, we used this stalagometer, where this pipe was used for we used here a drop count method. So we counted the number of drops from the stalagometer tube, and in the simultaneous way we have calculated our surface tension. Now coming to results and discussion, the results are basically, this is the tabular format of our various data which you have gained from the experiments. So here first come in this heat of combustion value. This is basically I separated three sets basically to analyze the results in more clearly. So this is only for binary blending of isopropanol jet fuel and ethanol jet fuel. So here this is the fuel compositions which we are denoting. This is the heat of combustion value, and this is basically decreasing trend, because obviously the number of carbon which is decreasing, that is why only the heat of combustion value is decreasing. Similarly, the effect can be shown in viscosity. Surface tension is more or less kind of a constant in all the blending fuels, and but density, there is density, we didn't find any trend in density, so it just randomly came. But here I want to mention ki this heat of combustion values which we have got for this jet fuel 70% and 2-propanol 30%, and this jet fuel 80%, 2-propanol 20%. These all values are these all values falls under the basically this threshold value which is given by the authorities. This is to another set B and set C. This is to another set of results. So here only I am showing the heat of combustion values for these two, and this is also always, this is also, this is decreasing, this is decreasing. This is basically because I am reducing the percentage of the jet fuel, and also I am using different kind of oxides. This is mentioned here. And here we couldn't calculate the surface tension and viscosity, because this was a millimeter dimension, basically the oxides which we have. So that's why our instrument which we have in our lab, that cannot determine these values. So in conclusion, basically we can see this jet fuel 90 and 2-propanol 10%. This produced a heat of combustion value of 44.23 megajoule per kg, which satisfies the ASTM standard. So that the thing which I was talking about. And finally, this can be, I will consider that this can be used for further extension of research, which can be lead to blending fuel without, which can be used in commercial vehicle without any kind of modification in the engine. So these are the reference, and thank you.
So, Arghya, you had an objective of finding out rather new suitable fuel by blending already available or used fuels, is it?
Sorry, sir, I couldn't get it. Can you please repeat?
I'm repeating. So, your main objective is to create new fuel by mixing already existing fuel, is it?
Yes, sir. Yes, sir.
Okay. So, you have, on the basis of certain properties or criteria of fuel, you have tried to relatively evaluate the suitability of fuels, is it?
Yes, sir.
So, how many, the density, surface tension, and then you have talked about the calorific value or heat value, is it?
Yes, sir. Basically, we calculated only 4 properties for the blending fuel.
But can you have just a brief indication that if these 3 values do not converge, then what will be your selection criteria? Is the question clear?
Sir, basically, sir, there is nothing to converge or divergence here. Basically, ASTM is a body which regulates the standards values for fuel properties, which should be there to use in commercial vehicle. So if this fuel doesn't fall under that conditions, basically, then we should ignore it. We should
Great.
not consider it as a fuel.
You have rightly pointed out there is no question of convergence or divergence. But then what, the purpose, for what purpose you are measuring these properties then? How does it help of selecting the proper fuel?
So based on that esteemed standard,
Okay.
that was the only sole criteria for that.
Okay. So anybody else can Partha?
Yeah. There are two aspects of your work. One is mixing the fuel, and other is using the catalyst. You have mentioned that presence of catalyst decreases, I mean, decreasing the combustion efficiency. Am I correct?
Yes, sir. Basically, we have used different kind of catalyst, but we have seen ki the combustion values is decreasing. We tried to
Now,
find
my
out the
point
results,
is,
but
a catalyst may be positive or may be inert. How it become a negative catalyst?
sorry, sir, that
Why
I didn't think in that
why
way,
do
but
you hold the catalyst to be responsible for the decreasing value? It may
yes, sir.
remain inert as such. Number one. Number two is, did you synthesize the catalyst or obtain from the market?
No, sir, we didn't synthesize. These are readily available in the market.
Yeah, right. So in that case, it is believed that its catalytic criteria is written, right? And it is standard.
Yes, sir.
So what is your opinion about that? There will be other reason for decreasing the combustion trend. Uh, it is not the catalyst what is responsible for that.
Actually, sir, basically there was only two fuels. One is jet fuel, another one is catalyst. So jet fuel, obviously we are using 95% jet fuel and 5% catalyst. So uh, we are
Do you
solely
think the
looking for the
outcome is
catalyst
weighted
only.
average, or there is some interaction issue in that between these two fuels? Is the
No, sir,
outcome
this
just
is a
weighted average sort of, or there is some interaction phenomena which may increase or decrease their performance?
this was, sir, weighted average.
Weighted average. There is no, I mean, interaction possibility which can influence the efficiency.
Yes, sir. Actually, our main intention was that if this catalyst can interact with the fuel, but initially we thought that, but
My point is,
that
if it
didn't
is just
happen.
weighted average, there is no point of conducting experiment or even research. So, I mean, there should be some scientific issue when you are mixing these two components, right? And
Yes, sir.
the role of catalyst. Anyway, thank you.
Thank you, sir.
Okay, anyone else of the board? Somebody has any query? Niharta? No. Okay.
Oh, thanks very much. It's good.
Okay.
Yeah.
Thank you. It's good. So it's Orgo, I think we have made a good presentations, and then we can have the next candidate. Who is the
Thank you,
next?
sir.
Satota Mandal.
Satota, please join.
Previous one is here now.
Arghya Paul is over. Satota is joining now. Okay.
Yes.
But the
Yeah.
slide has to be removed.
He is sharing his document.
Oh, he has removed his sharing. Satota, go for the full screen and then start your presentation. And please try to keep it presentation with the maximum.
I will keep that in mind.
Yeah.
Okay. Is it visible?
Visible? Yes, it is visible. You can carry on.
Yeah,
Full screen.
Okay. So today my presentation is on can emotion mimic deepfake videos, a perspective on synthesia videos. There is the rapid advancement in the field of artificial intelligence enables synthetic manipulation in multiple medias like audio, video, and images. So it's very hard to identify that a video is real or not. So this changes are very indistinguishable from the real content, which makes identifying its authenticity most challenging. So the problem statement for our work is identifying deepfake videos, which is generated by advanced diffusion technology based on a synthesia tool. and detection of synthesized contents with emotional inconsistencies, and presenting it how much it is effective to use emotional inconsistencies to identify that a video is fake or not. So the objective of our work is leveraging emotional metrics, that is valence and arousal, to discern the fake contents and detecting fake videos generated by the tool Synthesia. So emotions are very hard to synthesize and include in synthesized videos. So that's why we are concerned about using emotional inconsistencies in the identification process. And the global survey by various research groups have identified that the users of artificial intelligence technologies are worried about being deceived by deepfakes. So in the process of data collection, we have two sets of data, that is real and fake data. So the real videos are collected from YouTube across different genres, and fake videos are collected from Synthesia with same captions from the real YouTube videos. So those videos are collected from 3 available templates in Synthesia, that is medical reports, tech videos, and weather forecasts. And all these three for all these 3 templates, we have collected videos for 6 ethnicities equally across male and female genders, which includes Indian, African, American, East Asian, European, and South Asian. So Synthesia is a platform whose working procedure mainly based on human RF technology, which reconstructs spatio-temporal radiance fields and captures human movements with high fidelity. So this combines other technologies like natural language processing, generative adversarial network, generative AI, and LLM. So this helps to create lifelike avatars, which are specifically used for marketing, education, and corporate communications. So valence represents emotional positivity or negativity. That is, high valence represent a person who is very happy, and the negative low valence represents emotional negativity. That is, a person is how much sad. And similarly, arousal is another emotional cue which represents emotional intensity. That means high arousal means a person is very excited, and low arousal means the excitement in that person is less. So from in the first our proposed method, that is statistical method, we have observed that fake videos depict high valence. That is, the videos that is generated from Synthesia represents very much positivity in those facial structures in their video, and the real videos that is collected from YouTube depict high variability in arousal. That is, in the real videos, we can see that emotions vary more in intenseness. So our key parameters for our observation is area under the curve for detecting high valence and standard deviation for detecting variability in arousal. So we have used various supervised classifiers, which is trained with this standard deviation, area under the curve parameters, and the training and testing ratio for the classifiers is 85% and 15%. So in this table, we have used various classifiers. Among them, for the whole data set, the decision tree performed better, which has achieved the accuracy of 87%. And we have also tried to see the accuracy level for different templates. And for that, like for weather forecast template, the ensemble method worked better, or maybe for medical report, the SVM has worked better. So for each template, the classifier, different classifiers work better. The second proposed method is deep learning based method, which where the main principle for it is a temporal variation in facial expressions analyzed for authenticity through vision transformer. So for this, we have collected these real and fake Synthesia generated videos and divided into training and testing ratio of 90:10. And we have divided all these videos into frames and the FPS, that is frame per second, is 10. And then we have converted these frames of an input image of 224 cross 224 RGB format, and we have resized this image to 72 cross 72 pixel. and divided each image into 6x6 pixels. So this results in total 144 patches per image. For each RGB images, elements for each patch becomes 108, and we have manually verified the quality of extracted face regions. So this is the pre-processing process which I have followed in the vision transformer model, and this is the architecture of the model which I have used in this work. So for the whole data set, we have achieved the accuracy of 98% for fake and real class. We have also tried to see the accuracy level for different each templates for each ethnicity and for male and female, both genders also. So in conclusion, the real videos display different emotional complexity than synthesia-generated effects. And the vision transformer model proved that temporal variation detection is effective and outperformed statistical methods in accuracy. And emotional cues like valence and arousal become a robust framework which can establish to address future defect identification. In future, we can diversify our dataset with more templates which are available in Synthesia. We can also include a different platform which may be based on different technology to identify that these emotional cues can identify that these videos are generated or not. And for emotion detection, we can also include audio, speech, rather than just only facial expression from images, which can also lead the identification process. So I would like to acknowledge to my supervisor of this work, that is Professor Ruchira Nashkar, and this work is also funded by Science and Engineering Research Board, Department of Science and Technology. These are the references which I have followed. Thank you.
Thank you, Satota. I think somebody has asked some questions, specifically Ashirbani. Would you like to start with?
Yes, I have some questions. Thanks, Sudipta. Very nice presentation, Satota Mandal, very crisp. So wanted to
Thank
know,
you.
Did you develop template-specific models, or you develop just single model that applies across all the templates?
A single model which is applied across different templates.
Okay, do you think a template-specific model would help you to achieve a better performance?
Maybe yes, but I think I need to delve more to enforce this statement that yeah, it will be better if I can create a template-based model.
Okay,
I need to delve more.
Okay, so I think the model that you developed, it actually makes a contrast between the videos generated that from Synthesia and from YouTube, right? Do you think that this model is going to perform equally well, or at least comparative to the videos that you take from other sources, like deep and fake videos from other sources? Have you tried applying those?
Actually, the Synthesia, I haven't get a more authentic source of getting deepfake videos, but I think it will vary because the technology which is used in Synthesia platform is different, and its application is different. So if I look about another resource, so it is going to vary because maybe that the technology behind it will be different. So from the statistical observations also, we can say that will be different because the Synthesia is created in such a way where the emotions will always be high because no organization will create a fake video with something hurts or sadness created, or something where people are very excited, or maybe the changes in the excitement will vary a lot. So I think it will vary for different platforms.
Okay, thank you. Those were my questions.
Thank you, ma'am.
Satota, just a observation. Sudipta, just not a question.
Sure,
Satota, you improved a lot last year. I remember watching you, and congratulations, you progressed. That is the objective here. So you are much confident, much precise. Keep up your good work.
Thank you.
Yeah,
thank you so much.
Yeah, absolutely. We are feeling that you are improving much. So the one issue is, can you just tell us the application area? You are telling that the identifications of fake videos sort of thing, is it?
Yeah, like nowadays it's quite common, or maybe I don't know, have you seen this or not? Like last year, it was very famous that I'm taking a real life example that Amir Khan has said something like this, which he didn't say. So for these kinds of videos, that is, it is synthesized or generated from some kind of platform using real life avatars. So yes, it is like very much relevant nowadays to identify that, to check the authenticity if a video is real or not. So yes, it's very much applicable in real life.
Okay. Anybody else has any query?
It is not a query, just a suggestion. I mean, uh, what I understand that you are dealing with certain emotional features in the videos. So,
Yes.
do you think that if you consult a psychoanalyst who are basically domain experts in expression of emotions, I mean, you could have, I mean, more dependable parameters or more better correlation with your emotional expression and outcome?
Yeah, I'm also looking into that because a recent work of, not recent, Paul Ekman, there is a researcher who has worked a lot along this field of emotion detection from facial images. So even her daughter is also going along this way, who has worked with stress also. So yes, I am following these works, and yeah, I agree that if I take some suggestions from those medical fields, it will be more helpful. And yes, in this semester, I'm working on that.
And
Thank
as
you.
you have considered different a wide cross section of ethnicity, do you think that expression of this emotional parameter vary across the ethnicity, and can that affect your interpretation?
No, I don't think so.
What is your observation? I mean, yeah.
Like the spatiotemporal features which is used in vision transformer also, or maybe the model which we have used to collect emotion from for each frame, there the ethnicity is the skin color, or maybe the other styles is not going to
I
affect
mean,
much.
intensity of expression.
Sorry, can you please repeat?
If I get excited, my intensity of expression, and say someone from
Hmm.
Africa or somewhere else,
Hmm.
are this expression matters in your analysis? Intensity of expression, what I say.
Uh,
I'm not in the
no,
domain.
like
This is
if
just
I'm
layman's
saying
query.
for no, actually, I don't know if I'm getting it right or not, but there is a cue that is in arousal. So if I am saying for an Indian person that yes, for this frame or this expression, it is high arousal. That similarly for a people who is from Africa, for that African people also, I will say that yes, for these features, it is high arousal. So I think ethnicity is not going to affect much.
Okay, okay. Thank you.
Yeah.
It's a brilliant presentation.
Yeah, good.
Thank you.
So our alumni Deval Banerjee has raised his hand. Maybe he has some query. Just very shortly or briefly, if you can have your query, please, or
Sure,
discussion. Yeah, sure.
sure, absolutely. So, Satota, you picked up three samples for your study and analysis. One is weather, one is technical, and the other one is medical. Whereas when it came to giving an example, you picked up a social topic of Amir Khan saying something, whether he said or not said. My question to you is, why did you pick the three examples for your study from medical, from technical, and from weather? What are the chances of deepfake videos originating from these three samples? That's it. And
Okay.
by the way, excellent presentation, very confident. I am impressed.
Thank you. Thank you so much. I would say at first that choosing the medical report because medical field is a very critical, and if someone gets someone like do something manipulation in this informations, it will have a catastrophic effect. So that's why. And technical is because we are from engineering background, so keeping that in mind, and we have a target to to go for all the available templates, but the subscription needs more money, and we don't have that grant to go for other reports also. So that's why I'm not able to explain more. And for the weather forecast, we were looking for news telling, a person telling news, because that is also something very crucial to have real data to get real information. But there was some legal issues using news captions from YouTube videos for Synthesia tool. That's why we have moved towards weather forecast something. So that's why just only these three templates. But I would like to explore more if I because of the grant
Yeah,
limitations.
if you
I'm not able to
understood,
explore more.
if you expanded your study with samples on socioeconomic, religious expressions videos, you may find very interesting results. But that's pretty much it. Thank you very much. Thanks a lot.
Fine, Satota, you have just inspired all of us to discuss with you, and we are very happy. And I think we wish you a very good future career in your research. So all the best from us. And thank you. The next candidate, and Ashirbani, you can just conduct the rest part. Yeah.
Thanks, Sudipta. Our next candidate is Bishesha Dash.
Vishesha Dash.
Bishesha is from mechanical engineering. And Bishesha, please start your presentation. Hi, Bishesha. Your slides are up. We can't hear you.
Oh, okay. Sorry.
Okay.
Yeah, so good evening, one and all. I'm Bishesha Dash. I'm a third year undergraduate student in the Department of Mechanical Engineering. I'm going to present my paper on adaptive fuzzy predictor based fast terminal sliding mode controller design for two-link robot manipulator. It was presented at the Indian Control Conference in IISER Bhopal in December 2024. And our guides were Dr. Roshni Mehti ma'am from the Department of Electrical Engineering and Dipayan Guha sir from MNIT, Allahabad. Starting with what are we trying to do? What are we trying to solve? We are trying to develop a controller which can be applicable in the real world scenarios. The question arises that what are the challenges in the real world scenarios? Firstly, our system is non-linear. And secondly, we have time-varying external disturbances that we have to reject. So next comes as that why have we chosen two-link robot manipulator? Why not three? Because the reason is it gives us a fundamental model through which we can explore various control strategies. Coming with some background, we have SMC, the sliding mode controller. The problem with SMC is it suffers from chattering. Also, we have TSMC. Here we get faster convergence to our results, but it has problem with singularities. And also we have FTSMC. But the problem here comes in the presence of time-varying external disturbances, and thus we need a hybrid approach to our solution. So here we will first estimate the disturbances using adaptive fuzzy predictor and then address the nonlinearities using FTSMC. So this was the experimental setup that we used. You can see that we have used two-link manipulator and we use servo motors which were controlled by MATLAB and Arduino Uno. And these are the link lengths and masses of the links that we used for our robot. So for the system model, we have 4 state variables that we use to define our system: θ1, θ2, θ3, and θ4. We use them to define the angular position and angular velocity of the system. Coming to the system models and the system dynamics, we derived the system dynamics using Lagrangian formulations. And we got the θ1 double dot and θ3 double dot, which are the angular accelerations of the two link. The proposed methodology that we used here is we are using the adaptive fuzzy predictor to estimate the disturbances. and then FTSMC to remove those disturbances. And since it is a sliding mode controller, it will remove the non-linearities. One thing here to focus is the theta tilde here. That is the error that we are getting from the differences of the thetas, one from our system and one from our predictor. Coming to the adaptive fuzzy predictor part, fuzzy logic controllers are universal approximators which can be used to estimate the time-varying disturbances. And here we are using some if-then rules, which will give us the model dynamics of the predictor. So this is one of the if-then rules that we used here, and we are getting the theta 1 double dot and theta 3 double dot, that are the angular accelerations of the system. And combining these equations, we are getting the fuzzy predictor model. You can see that D1 and D2 are the disturbances of the system. Summing all of these thetas, theta 1 and theta 3 dots over Q rules, we get the fuzzy predictor model. Coming to the error dynamics, Coming to the error dynamics part, we have theta tilde, which was the difference between actual state and predicted state. And this is the equation that we are getting for it. For the stability proof, we have to ensure that our system that we have designed is stable. So we are using Lyapunov candidate vector, which is shown as this. And V0, V0 is the quadratic energy function, and the derivative of the energy function is V0 dot. So the predictor will only be stable if this condition holds true, which means we have to equate the positive part of the derivative, that is the V0 dot, to be 0, as we want it to be a negative definite. Thus, we get the equation 9, and from that we get equation 10. So these are the predicted disturbances that we are getting using the adaptive fuzzy predictor part. Coming again to the sliding mode controller part, we have the accurate tracking for nonlinear systems. And to estimate the non-linearities, we are using this. For the stability, as mentioned before, we are using the Lyapunov functions, and it will effectively reduce the chattering. These are the sliding surfaces and the equation for the sliding surfaces. We have chosen the values of P and Q such that this condition holds true, as we are using the Lyapunov candidate vector. Coming to the after taking the sliding surface equations, we are deriving it and substituting for theta 2 dot, and we are getting these equations. And our control input is tau, which is the joint torque on the links. So we are getting tau 1 and tau 2. So that is it for the controller part. Now coming to the results, our reference signal is shown here as blue color, as you can see here. And you can see that our proposed AFP FTSMC is able to reject these disturbances, which the baseline TSMC was not able to do. So successfully, our AFP is able to predict those disturbances, and the FTSMC part is able to reject those. And here is the control signal that we gave for our TSMC and AFP FTSMC. So coming to the result part, like how we compared the improvement of our strategy, we used integral absolute error. Here you can see for TSMC, we got these values as errors, and our proposed AFP FTSMC was able to reduce those errors to the great extent. The observations from the results we got was reduced chattering in the control systems, and the disturbance rejection and tracking performance was very much increased. In conclusion, the key findings were we were able to achieve all the objectives in the real world system, where we have all the time varying external disturbances and a nonlinear system. Also, in our future work, we are trying to develop an energy efficient adaptive controller and to extend this methodology to a multi-degree freedom robotic system. These are some of the references that we used. That's it. Thank you.
Thank you very much, Bishesha, for your nice presentation. I have one question, and after that, I will ask other present here to ask you questions. So my first question is, you fixed the value of the masses, right? And
Yes,
you
yes.
have predefined lengths of the links.
Yes.
And
yes.
you tested with those parameters only. Do you think you're going to see the same level of improvement if you change the masses and change the lengths of the links?
Definitely. The result will not change as we are using just M1 and M2 that can change accordingly as we are not using any particular value in the equations.
Okay.
We are using it as variables.
So my second question is related to that. When you write the rules for that, are you using any values?
While writing the rules, we are not using any values.
Okay, thank you. So if anyone has other questions?
Bishesha, you have picked up undoubtedly a rather not very easy problem. So that's good. I mean, you have taken that challenge. But I just want to know that you had some experimental setup. So was it in IIEST or outside?
No, we designed it here in IIST, and we set up also, the setup was also in IIST.
So your supervisor
We
is
3D
from
printed the model.
Yeah, but his supervisor is from electrical.
Yes, electrical department from
Also,
IIST.
this has been installed in electrical department.
No, it is a remote installment. Like it is not fixed. We can carry it anywhere.
Okay, okay. Because you have carried out both the theoretical model and this experimental validations in this particular system, is it?
Yes, yes.
Okay, so we needed that. Anyway, so and the final query for me is, you have used so many equations which I have shown in the presentation. Do you understand that solutions of these equations method, or you don't need it at all?
Solutions as in?
I mean, whenever you are showing some equations as a part of your work, you need to know the solution methods of those equations also, isn't it?
Actually, some of the equations that we used, we have taken the derivatives and substituted it in some other equation. And for the equation that we have substituted in it, we need the solution for that equation. So I know the solution methods for the equation that we have substituted into.
Okay, fine. So anybody else?
What controller did you use, Bishesha?
Fast terminal sliding mode controller with like the adaptive fuzzy predictor part was the addition to it.
No, but is it a like a physical controller that you used, or is it a simulated controller? What is it exactly?
No, we coded the controller part.
Okay, you coded the controller. I understand.
Yes.
And the prototype of the robot that I see, the black one on the screen right there, did you create the prototype yourself?
Yes, using SolidWorks. Yes.
Oh, okay. Okay. All right. Thank you.
Thank you.
Do you have any more questions? Okay. Thanks, Bishesha, for your nice presentation. I think we can move on to the next presenter. Our next presenter is Shreyas Kumar. Hi, Shreyas.
Yeah. Good evening, everyone. Am I audible?
Yes, you are. Shreyas is from mechanical engineering. Shreyas, you can start your presentation now.
Okay.
Thank you.
So, good evening, everyone. I'm Shreyas Kumar. I'm from the Department of Mechanical Engineering, and I'm about to present my work, which I carried out last summer as a part of my summer research internship at IIT Gandhinagar. So the work is iterative learning for grasping and manipulation against unknown resistant fields that is generalizable to arbitrary trajectories. So that sounds quite complicated. I'll try to keep the presentation as lucid as possible. So the table of content, it is introduction, methodology, and then application of my method to serial chain manipulator, and then application of my method to grasping and multi-arm manipulation. Then conclusion.
Sorry, Shreyas, I'm stopping you for a minute. I do see your LaTeX open. Do you want to open it in presentation mode?
It is open in presentation only.
Okay,
Let me
but
just
it's
share
part
my
of the
screen
lab.
again.
If you're okay with it, I'm okay with it, I think. Thank you. Please move on.
Okay, I'll just try. Oh, I was sharing the wrong screen. Yeah, is it better now?
Yes, now it's perfect. Thank you.
Okay, thank you so much. So the table of content, as I was saying, first is introduction, then methodology, then application of my method to serial chain manipulator, then application of method to grasping and multi-arm manipulation, followed by conclusion, acknowledgement, and references. So what is the motivation? Like, why am I doing this work? Like, what is the problem that we are trying to solve? So the robots these days, they tend to be very dynamic. So they have to operate in unstructured environments where traditional learning methods, they face several challenges. And some of the challenges are training dependency, which is they require extensive pre-training, again, which is impractical for real-world deployment. Slow adaptation, they're not able to adapt to changing resistance field or like just changing task conditions, and high computational demands. So they require a lot of resource to be trained. Now, proposed method. So what we are doing is we have proposed a novel iterative learning control-based approach. And the novelty is that we can deploy this directly without prior training in simulation or hardware. And the method can rapidly adapt to unknown resistive fields or closely related tasks or environmental changes in very less trials. And it is very simple in computational terms. So it's just one equation which we are trying to use it in very beautiful ways. Now, what is generalization? So generalization in ILC specifically is applying your learned skills to new scenarios. The scenarios can be new, but it has to be a bit similar. So that is one of the limitation. But yeah, so like a lot of work has been done and there has been some proposed enhancements in ILC, which is including transformations and then a few others, which I will be covering throughout the presentation. So we have also done experimental results which validate the effectiveness and the claims that I'm going to make. So iterative learning control for field learning. So the traditional method is just u of k plus 1, which is the next control input, is equal to some constant times your previous control input plus some constant times your error. So this is a very simple equation which turns out to be very powerful depending on how you use it. Now, learning control input for resistance field is something which we are going to do. So this equation will be learning learning the control inputs when the inertia of the object is unknown, when there are different forces acting on it, external forces acting on it. And okay. And then what we have done is we have tried to simplify the application so that we can control nonlinear robot dynamics as well, which is again, I'll be explaining in the upcoming slides. So yeah, trajectory independent generalization of learning. So now let's say I have learned a trajectory using ILC and I want to generalize it to a different trajectory. So because my this relationship is linear, I can scale it and rotate it to create a different trajectory. So this equation is essentially that, where SF is my scaling factor and R is my rotation matrix. An extension of this to basis learning. So now the beautiful part is I can just take these trajectories and I can create small trajectories which can be line or parabola or cubic curves, and I can just merge them together to have a control input for my new trajectory. So the advantages are it reduces the need for exhaustive training and it allows for deployment to new tasks efficiently. So yeah, the first thing, application to serial chain manipulator. So here my task is to cut through unknown material and learn the resistance field over trials. So here what we are doing is development of a virtual system integrated with ILC-based learning approach and the application for cutting materials of unknown resistance, which is one banana and a cucumber. And we'll show how using ILC, just one equation can do wonders. So first we have a virtual system, which will linearize our nonlinear dynamics. And the virtual system is modeled as the massless Turdorf spring damper system, as shown in the figure. And we have done feedback linearization to, again, transform nonlinear dynamics into linear space. So this is the control law. And once you put this control law, your Coriolis and this gravity part would cancel out, and you would have this beautiful linear second order differential equation, which can be controlled using ILC. So this is the control framework. We have our ILC, we have our virtual system, then feedback linearization, and then the manipulator dynamics. Now, the experimental setup is an open manipulator X with dynamic cell motors, and it has been modified where we have included a cutter blade for precise cutting tasks. So now the scenario was cutting a banana and a cucumber, and what happens is the blade initially cuts the banana and it learns the resistance forces for trials 1 to 34. So it is iterative learning control. So I'm going trial by trial. So as from 1 to 34, the blade learns to cut through banana. Now suddenly I'm introducing a cucumber alongside the banana. So the robot detects this increased resistance and stops cutting to prevent damage. So this is one claim, that is the safety of iterative learning control. So the safety mechanism is activated on its own and the cucumber remains uncut. Like, I would like to emphasize that this is just one equation which is acting. We have not done anything else. And I will show the evidence, and which is here. So as you can see, till trial number 33 and 34, the blade position along the X is reaching a certain point. But as soon as I place the cucumber, it is stopping here. So it is not going beyond the cucumbers. It stopped cutting. And it is learning it is learning that new resistance field iteratively. So these yellow shaded regions are the forces when the blade is cutting the banana, and the green ones are the graphs where the blade is cutting cucumber. So you can see trial by trial, the input force is increasing. So here it barely touched 2 newtons, and here you can see it has crossed 2 newtons. Now, so the conclusion, it validates the robustness and adaptability of the proposed method, and it demonstrates the safety feature, which was a claim that I made. And it also highlights potential for real-world applications. And one of the most prominent applications that comes to my mind is human-robot collaboration. So it can safely interact with humans in unpredictable conditions. Now, application to grasping and multi-arm manipulation. So here we have taken a planar 2-finger robots, and the task is to move an object from one point to another point. So to move the object from one point to another point, I need to apply forces on the object. But my input is joint torques. So I've used grasp matrix and hand Jacobians to go from the object wrench to joint torques. Now the thing is, while trying to move an object using just 2 fingers, it gets very unstable. So I need something externally to stabilize it. So to stabilize my grasp, I have used a path-dependent object impedance control, which essentially makes the object behave like a spring damper system. And so if it is deflected a bit, it will try to bring it back to its desired trajectory. And it is path-dependent because as the trajectory changes, it has to show that impedance behavior throughout the trajectory. Now, I also had to include this perception model, which is combining the camera input of the object position with the proprioception model. So I'm getting the position of the object using my joint angles, and I'm getting the position of my object using camera. So I've used the EKF to fuse this data so I can have my data update at a higher frequency, which is 100 Hertz. Now, this is also something novel in our work, which is a adaptive null space controller. So what we are doing here is, the goal is to maintain a stable grasp by ensuring consistent normal force on the object. So the null space controller operates in the null space of the grasp matrix, which avoids interfering with the object manipulation. So it will apply no forces in the tangential direction, it will only apply forces in the normal direction. So that is why the normal components are being projected in the null space of this grasp matrix. And then the combined forces comes from FILC, which is the learned force to manipulate the object, the impedance force, and then the null forces. And combining all of these 2 things, I'm calculating my joint torques. So this is the control framework where I've just put together everything that I explained. And this is the experimental setup. Again, we are using dynamic cell motors, and this is a 2-hour robot, which is planar. So now the experimental results. So the primary task is to move along a straight trajectory, and it was able to do it using ILC for 30 iterations. And once I have this learned force vector, the U input, I can modify it. So I've scaled the trajectory along x-axis by 1.25 for scenario 1, and I have rotated by 135 degrees and scaled by 0.75 for scenario 2. Now, if you can see the normalized error, it reduces over 30 iterations and it reaches here. This blue zone is the learning phase. And now, just in 4 iterations and just in 3 iterations, it is able to generalize. So it is able to do those 2 scenarios in just 4 iterations. So you can see the error is just dropping drastically in very less iterations. So this is the power of, again, just one equation. Everything is happening with that one ILC equation. Now, if you can see the trajectory tracking performance, so this blue was the initial trial, and this red is the final trial, where this yellow is the desired trajectory. So this was over the learning phase. Then this is for the generalization phase, where in just 4 trials, you can see how effectively it is able to trace the trajectory. And this is again for the generalization phase 2, where you can see the purple one is able to trace the trajectory very efficiently. So the conclusion is we have developed a novel ILC approach for robots to adapt in unknown resistance fields, and it addresses the challenges of safety, rapid learning and adaptation, and competition efficiency. Because again, it is just one equation. So so I would like to thank everyone who has played a part in helping me get here and be able to present this presentation. And I'd also like to thank GAABESU for giving me this opportunity to present my work. And these are some of the references I have used.
Okay. Shreyas, very nice presentation. I have one question from your first experiment or first project. And the question is, how do you decide that you need to proceed up to 35 trials with the banana before offering a cucumber?
Okay, so considering the time constraints, I had removed some of the graphs. So what we are doing is we're taking the normalized error. So once the normalized error drops and the previous one is lesser than a certain threshold, we decide that, we have to stop now.
Okay, so you have a predefined stopping criteria?
We have a predefined stopping criteria. So once the error is converging, and it reaches a less value, like the previous one and the current one is less than a certain threshold, it will stop.
Okay, just one question. Do you think that this error should depend on the material through which the robot cuts?
Definitely, it will depend. That is why we had used that. For different resistance fields, it can certainly take a different number of trials. So that is why we had used that threshold. We had not stopped at a particular number of trials.
And so the threshold is independent of the material. That's what you're saying.
The threshold is independent of the material.
Okay, thank you. Any more questions from the group?
So whenever you're talking about the resistance, do you mean the force?
The resistive field. So when you're trying to cut through a banana, there will be some resistive field which is acting on that on the blade. So that is what I'm talking about.
In that case, my point is basically it depends on the material, it depends on the angle, it depends on several other factors also. So what exactly is typically interpreted by the term resistance? Mathematical expressions leave it.
Your voice is echoing. Could you please repeat?
I'm telling that whenever you are cutting a particular material, am I clear? So in that case, there are several factors that can affect depending on the angle or the rate you want to cut it. So in that case, physically, what do you mean by resistance?
I'm not sure I got your question, but that is right, that it will depend on the angle that you're cutting and the resistive field. But in my ILC approach, I have this error term, and in that error term, we have defined the trajectory, the velocities, and the acceleration it should take. So everything is already, we have a desired position, velocity, and acceleration to follow. So it just tries to follow that, and irrespective of what the resistive field is. So that is something we have to set manually.
Okay, so I'm over.
Do you have any questions from the group? Okay, thanks very much, Shreyas, for your nice presentation.
Thank you.
Sorry, I think I was muted. Thanks, Shreyas, for your nice presentation. Our next presenter is Anuran Bhuya from Electronics and Telecommunication Engineering. Hello, Anuran.
Good evening, esteemed panelists, my dear friends, and everybody who's present here. Today I'll be presenting my research work that I undertook at the Carleton University in Ottawa via my tax. The results of this research has been published at the IEEE EDAPS Bangalore 2024. So I've tried to keep, my research work has been on improving a well-established algorithm via GPU acceleration. So I tried to keep it as lucid, as math-free as possible. I like to paint the picture of the algorithm instead, so that it resonates with a lot of people. So the key motivation of this algorithm is to simplify the circuit simulations when it comes to higher order circuits, as well as considering various factors that could be modeled into higher order circuits. Like when we're dealing with high speed circuits, the various parasitics and the crosstalk between them can be modeled as poles of circuit to enable more approximate modeling of the various physical phenomena. So this, we can see when taking into consideration all these factors, we could see the number of poles of circuits getting increased rapidly. And so does the computation cost. We've seen the general trend is the computational cost increase as the third power of the number of poles. So naturally, we find the need to have more efficient simulation algorithms, which can tackle higher pole circuits. So this is what I've been speaking about. And so one of the algorithms that can tackle higher order circuits is the PRIMA algorithm, or the passive reduced order interconnect macromodeling algorithm. It's basically a model order reduction by moment matching technique. So we could see this starts with the modified nodal analysis matrix, the M&M matrices from the very basics, and then it employs the Arnoldi algorithm, which uses a Krylov subspace to generate the transformation matrix, which could congruently reduce the size of matrix while preserving the passivity and the accuracy of the simulation. So I'd like to touch upon the modified nodal analysis equations first, since we'll be using these matrices quite a lot in our algorithm. This is the basic equation that we've learned in network theory in our classes, where the C and G matrices are the conductance and the susceptance matrices, and IN and UN are the vectors denoting the port currents and the voltages respectively. So now coming to Arnold algorithm, this is the block in the PRIMA algorithm, where we are generating the X matrix, which basically transforms the N pole circuit to a Q pole circuit, where Q is obviously very less than N. We do this by spanning the Krylov subspace generated by A and R, where A is G inverse C and R is G inverse B, as we can see in this modified nodal analysis. So we're still dealing with the system parameters. So the steps in PRIMA are detailed as follows. To implement PRIMA in GPU, we had to tone down our approach because GPUs don't work the way CPUs do, and we have to heavily parallelize the structure of the algorithm so that it was more suited to GPU applications. So I just run through the steps in PRIMA. The LU decomposition to solve for G inverse C, the Arnoldi algorithm block, and then the Arnoldi algorithm block generates the matrix X, which congruently reduces the sizes of G and C to GQ and CQ, so that the matrix sizes are reduced and we could deal with lesser number of lesser sizes of the matrices. Then we have the LU decomposition to solve for G inverse Q and CQ. Then eigen decomposition of HQ, which further simplifies the calculation of the responses. And then we compute the poles and residues and compute the responses of each port. For GPU acceleration, we tackle each step at a time, starting with the LU decomposition and then the Arnoldi block and the congruent transformation in the first phase. So I'll be referencing this slide a lot because this outlines the algorithm in a very lucid way. So first of all, we can see GR is equal to B. So to get the R matrix, we need to find G inverse B. And as we all know, for large matrices, large dense matrices, calculating the inverse matrix is very computationally expensive. So we have got other ways to calculate inverse of matrices, namely the LU decomposition, the lower upper decomposition, which breaks the G matrix into two matrices, two lower and upper matrices, which can then be easily used to find the inverse. Then we go to the block Arnoldi, where the X matrix is generated and it's of the dimension n into q, right? So we first create the Krylov subspace and then we span it so that it iteratively fills the columns of the X matrix. So once we've got the X matrix over here, we do the congruent reduction, which is the C tilde by X transpose CX and G tilde as X transpose GX. For this also, we need the LU decomposition because the transpose and the X transpose and X multiplied with C, since C being an n cross n large order matrix, it was computationally very expensive. So we again had to design an LU solver for GPU to calculate C tilde and G tilde. And then we do the eigen decomposition of G inverse C as S lambda S inverse, where lambda is the eigenvalue matrix, where the diagonal elements are the eigenvalues, and the S is the matrix of eigenvectors. So when we're dealing with diagonal matrices, the multiplication becomes very easy. So then calculate the poles and residues, and since we already have G inverse C as the product of eigenvectors and eigenvalues, so we are dealing with the diagonal matrices, it becomes computationally much more cheaper to get W, as we can see over here. Then we calculate the intermediate parameters mu and V, which are then used to calculate the Y response, the same Y response we have in our transfer function, and approximate this circuit simulation. So what Prima algorithm does is it reduces the number of sample points while maintaining the accuracy and passivity of the circuit, and it has been further enhanced by GPU application. It has further been parallelized to suit to use GPUs. So we arrived at these results, where the original one, which we calculated using MATLAB, it took us 4 days to simulate the original graph, and then we used the GPU Prima algorithm, and we could see that barring a few offshoots at higher frequencies, the GPU Prima almost approximates the original response. The original response has been calculated through the modified nodal analysis and brute force, and Prima is the approximation. So here you could see results of 2 of the ports, and here also we could see one of the shortcomings of Prima algorithm, where at higher frequency it starts to break off. Excuse me. And this is the computational cost that we have compared regarding CPU and GPU, where the sparse LU solver didn't provide us much advantage over the CPU, But as you can see, the block Arnoldi part, where the CPU takes 238 seconds, the GPU does it in 1.71 seconds. Similarly, for the congruent transformation, as it involves, X transpose X and C, they were very dense matrices. It took 16 seconds for the CPU to compute it, where we can see the GPU did it at only 0.56 seconds. Similarly, for the dense LU solver, 8 seconds versus 0.5 seconds. So overall, we gained a speed up of 11.34 times, where the total time was significantly reduced. And we can also see that the error, the RMS error, is due to the shortcomings of primer and not shortcomings of, messing with the sequential structure and porting it to a parallel structure. We have almost matched the accuracy of, we've exactly matched the accuracy of the CPU version with the GPU version. Now, one of the shortcomings I would like to point out is that I was not able to design the GPU version of an eigen decomposer, and which I intend to do in the coming months. But these results are pretty much very significant when it comes to higher order circuit simulations, and we must use GPUs. The GPUs are the way forward in circuit simulations. Gone are the days where we could use sequential programs like LT-SPICE and MATLAB. Like I stated, along with the eigen decomposer, there is a much more efficient QR decomposition, which further improves the performance when calculating calculating multiplication of matrices, the dense matrices. So that is one thing I'm exploring. And that's my conclusion of the research work. And these are the references I used for my research work.
A very nice presentation, Anuran. Would you please describe the details of the CPU and the GPU that you used for this simulation testing?
Both were remote servers. The GPU I used for used on Compute Canada, the Narwhal and the Graham clusters, GPU clusters, the A100 GPU clusters I used on the Graham and Narwhal servers. And for the sequential part also, it was a very high performance CPU that was also provided from Compute Canada. Okay. And I coded it on MATLAB.
Okay, thank you. So do we have questions?
I don't have any question for him.
Sorry, Sudipta, your voice is cracking.
I don't have any question for him. Okay.
Okay. Thanks, Sudipta. Any other questions?
Look, one question, can I ask?
Yeah, go ahead, Anubhav.
Yeah, so Anuran, great presentation. So what do you think about this algorithm performing when you have higher precise computations? For example, floating operations around 64.
Right. So we use the magma routines, which allows for double precision in matrix calculations. So I think it would still hold up pretty well for high order, because for this one also we tried using 60-port network, and then after this was published, we also tried with 120-port networks. So you can imagine the size of the matrices. It's 10 to the power 2. It's almost 10 to the power 2 times 10 to the power 2, right? So it's a 10,000 element matrix, and each of these has 120 ports, right? So it was quite computationally challenging, but it did still hold up.
Sure. And one more question, just for your future work. When you're using GPU, was the CPU idle, or you're using the CPU as well? Can you use both and parallelize both? Have you thought of that?
Yeah. Yeah, we did use heterogeneous programming. It was not purely GPU, like I said. There's certain steps like the eigen decomposition was done on CPU. So the CPU was just handing off tasks to GPU while it was doing its own routines in the background. And when the results came in from the GPU routines, it used those results in the subsequent sequential steps in CPU.
Okay, so those are standard interconnect protocols which you used to communicate the information coming from the CPU and GPU simultaneously?
Right. We use CUDA mem copy and device to host and host to device. Yeah, standard interconnect protocols. Yeah.
Okay, great work. Thank you.
Thank you.
Thank you very much, Anuran, for a nice presentation.
Thank you.
Thank you. I think we are at the end of today's presentation. Shapunda, would you like to?
Anybody has rather expressed willingness to join today?
Well, Sudipta, this is Bimanda. A question general for all the presenters, like if there is a template that how we are going to present, do you think it is of any value? Like I see that most of the presenters like shown their affiliation to the department, some of them not. And the other thing is like, since it is a GAABESU presentation, I would like to see on their PowerPoint on every slide, there is like a little template or a footer or whatever that mentions that this is a GAABESU Research Award presentation, because Shapon and his team is going to record or is recording everything. This will be archived. So I would like to see that our platform is acknowledged. And at the same time, I'm requesting all the presenters, I know we have another round of presentation next week, to invite their major professors who actually mentored and helped them in this work to see that how we are progressing in this kind of platform. So this is, I think, is a very, very good thing. I'm very excited to see these young minds coming and presenting. A lot of challenging environment exists over there, but at the same time, you're progressing, and I'm glad to see the growth and the thriving energy. So congratulations to all of you who came to up to this stage, and my personal congratulations again to all the winners who are present here. Thank you.
Very positive suggestions, two suggestions. So one is they can use that GAABESU logo rather in the presentation for getting it rather acknowledged as a part of the GAABESU presentations and other thing. And the second part is obviously they rather from the GAABESU, the invitation can go to their teachers. In that case, the students have to inform who are the teachers associated with these works. Otherwise, it's difficult. Rather, if there is a name of the teacher, etc., in their